All right. In this module, we will introduce the concept of conditional probability. So we'll start by looking at this concept through a simple example first, and then we will formally define the notion of conditional probability. So let's consider this experiment of tossing a fair six-sided dice. Let's write down the entire probability space that we have learned from the previous modules. So the sample space, so just to recap here, so you will have a sample space, which is the set of all outcomes. When you toss a six-sided dice, you'll get either one out of these six outcomes, numbers 1 till 6. So this is my sample space. Now, I will also assign some numbers, which are the probability numbers to these outcomes. So let's assume that probability of 1 occurring is same as probability of 2. All these guys are assigned the same value, which is 1 by 6. So this is a fair dice. So this is all outcomes are equally likely. Okay. Now let's think about an event. So let's say A is the event. So A is the event we observe 6. Okay. This is, and then we can ask, well, what's the probability of this event? So probability of this event A is probability of the outcome, the set of outcomes describing this event, which is just 6, which is 1 by 6, based on our the description of the probability space. Okay. Now, conditional probability is a concept and a very important one, which asks, sort of tries to answer the following question: that suppose we have additional knowledge about some other event. So let's denote another event, say B, as an event that we observe an even number. Okay. So what is the probability of B? So probability of the event B is the probability of the set of outcomes describing this event. So what are the set of even numbers in my sample space? It's 2, 4, and 6. Since they were all equally likely, this becomes probability of 2, which is 1 by 6, plus probability of 4, which is 1 by 6, plus probability of 6, which is 1 by 6. I'm adding them. I'm adding these three numbers because these are all mutually exclusive outcomes. Okay. So my answer is 3 by 6, which is 1 by 2. Now, conditional probability asks the following question: that what is the probability of event A? So the question that we ask is the following. So what is the probability of event A given that event B has occurred? Okay. So let's think about this first intuitively, and then we'll try to formally write down the proper definition of it. So in the above context, we can ask this question: what's the probability that we observe 6? Given, so this is how we formally write it. So given is written by sort of this bar. Given that we have observed an even number. Now, if somebody tells you that you have already that your outcome will be an even number, then in some sense the space of potential outcomes is reduced from 6 to 3, right? Now, out of these three outcomes, what is the probability? Okay, so the three outcomes are either 2 or 4 or 6, right? So you would expect that, well, out of these three, 2, 4, and 6 are all three equally likely among those three outcomes. So this answer should be 1 by 3, right? That's what you would intuitively expect, that given this additional knowledge, that given that we are observing an even number, what's the probability to observe one out of these three even numbers? So this should be 1 by 3. Okay. So formally, we can So this sort of intuition is crystallized in the proper definition of conditional probability, which I'm going to write this in this box. So the definition is given as the probability of A given B. So think of this as an event A and this as an event B is a ratio of two probabilities. It's the probability of A intersection B divided by the probability of B. Okay. Now let's think about sort of a intuition of this definition, why this thing makes sense. So this is, what is this guy representing? This guy is really representing the fraction of time that A occurs, or that A is expected to occur, once we know that B occurs. And our claim is that this is equal to, so since we know that B occurs, and then on top of that, we are asking, well, tell me what's the chance that A is occur, given that B has already occurred, right? So this ratio is essentially capturing this fraction, basically. Okay, so it's basically gives the proportion of time. So this is the proportion of times when B occurs that A also occurs. Okay, so essentially I'm just pretty much restating the obvious fact here. Okay, but hopefully this sort of gives you an intuition as to the definition, the mathematical formalism of the notion. Okay. Now, if you go back to our simple example of tossing a fair six-sided dice, we can also write down A given B for this example. So for the example, you can think of A given B is the probability of A intersection B divided by the probability of B, right? What was A? A was corresponding to the set of single outcome 6, and B was the set of even numbers. So sorry, 2, 4, and 6. So we can write down what is A intersection B. A intersection B is the set 6, and B is this guy, right? So if we can find this ratio, so PA given B will be the probability of A intersection B, which is the probability of the outcome 6, divided by the probability of this set 2, 4, and 6. So this will be the probability of the outcome 6 divided by probability of 2 plus the probability of 4 plus the probability of 6. Okay, each one of them is 1 by 6. So I can write 1 by 6 divided by 1 by 6 plus 1 by 6 plus 1 by 6. 1 by 6 will cancel, so I'll get 1 by 3. Right? So we can arrive at the same thing, same answer as we derived here, sort of in a hand-wavy manner, but we got it through the proper definition of it. Let's do another follow-up example within the same experiment. So moving on to another example. Suppose we toss 2 fair dice in succession. Okay. And then I'm going to worry about 2 questions here. So the first question will be, let's say, the following. So what is the probability that the sum of the 2 numbers I see exceeds 6? Okay. And then the second question I'll be interested in is, let's say, the following, that if the first dice shows up the number 3, then what is the conditional probability that the sum of the 2 numbers exceeds 6? Okay, so we'll work this example out in full detail. Before we do that, let's write down the sample space. So what is the sample space for this experiment? So remember, now we are tossing how many coins? We are tossing two dice, my bad, it's not coins, it's dice, two fair dice in succession. So we will have two things that would show up. We could have number 1 show up and then number 1 show up. Then 1 and 2 show up in the 2 tries, 1 and 3, all the way till 1 and 6. Then 2 and 1 is a possibility, 2 and 2 is a possibility, 2 and 6 is a possibility. And you know the drill, 6 and 1 is a possibility, 6 and 2 is a possibility, 6 and 6 is a possibility. These are all possible ways you can observe different outcomes when you toss two dice up in succession. Okay, what is the total number of outcomes here? Total number of outcomes is 36, right? 6 choices in the first dice outcome, 6 choices in the second, 6 times 6 is 36. I'm also going to assume that probability of every outcome, I comma j, is 1 by 36. Each one of them is equally likely. Okay. Now let's worry about our first question. So this in some sense gives me the full description. So this is my probability space. So this is my description of the probability space. Okay. Now with this out of the way, let's now work on problem number 1, part A of the problem. So I'm interested in the event. So let's call this as event A, which is the sum of the two numbers I see exceeds 6. Okay. Now let's write down event A. Event A is a set of outcomes. What kind of outcomes ensure that the sum of the two numbers I see exceeds 6? Let's write down all of them. If I get 1 and 6, the sum is 7, which exceeds 6. I get 2 and 5, 2 and 6, I exceed 7. 3 and 4, 3 and 5, 3 and 6, exceed 7. 4, 3, 4, 4, 4, 5, 4, 6, and so on and so forth. 6, 1, 6, 2, 6, and 6. So let me write down 5, 2, 5, 3, all the way till 5 and 6. How many total number of outcomes are there? The total number of outcomes here for A is 21 outcomes correspond to A. Any one of these 21 things happen, my event A is happening. Okay. Now let's write down. So what is the probability of A? Probability of A is the sum of all the outcomes in this set A, right? So it's the sum of all outcomes in A. What is the probability of any one outcome? Any one outcome, all outcomes are equally likely. So this number is 1 by 36. And how many outcomes are there? 21. So I get 21 times 1 by 36, right? So we can chop off stuff from top and the bottom, we get 7 by 12. Okay, so this is the probability of the event A that sum exceeds 6. All right. Let's go to part B. Let's now focus on, so let's read the question again. So the question was, if the first dice shows up 3, then what is the conditional probability that the sum exceeds 6? Okay. So after reading this question, the first thing you should try to think about is, well, let's think, since we are doing conditional probability, there'll be 2 events. So A is the event of sum exceeding 6. Then we should also write down the event B, which corresponds to first dice showing up 3. Okay, so let's write down that event. So say B is the event that the first dice shows 3. So what is this event in terms of outcomes? 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Now let's see, what is the probability of B? Probability of B is the sum of every outcome in B over all outcomes in B. How many outcomes are in B? 1, 2, 3, 4, 5, 6. 6 times. Each outcome is equally likely of probability 1 by 36. So I get 1 by 6. Okay. Now let's go back to our actual question. Our question was, what is the probability of A given B? A was sum exceeds 6. And B is first dice shows a 3. Right? From our definition of conditional probability, what is it? It's the probability of A intersection B divided by the probability of B. With that in place, now we can play the game. Now, what is A intersection B? Let's look at B and let's look at A, see what these guys have in common. Well, B has all the outcomes which show 3 in the first try. Okay, so, and then A has 3, 4, 3, 5, and 3, 6. So these are sort of the common parts. So we can take all of that and put it here. We're going to get 3, 4, 3, 5, and 3, 6 divided by the probability of B. So what will be the numerator? Numerator will be probability of this plus this plus this. So it will be 3 times 1 by 36 divided by the probability of B, which was 1 by 6. And what are we going to get? We are going to get 3 by 6, which is 1 by 2. That's our answer. Okay. So I hope the notion of conditional probability is clear. We'll build upon this and then do total probability theorem and Bayes theorem in the next module. Thank you.